In this lecture, I am going to show you all how to take the data from question 3 and to be able to um, basically calculate the standard deviations and the number of individuals that would be in each within each standard deviation. So right here, we have Miss Peacock, Mr. Green, Professor Plum, Miss Scarlet, Colonel Mustard, and I did change the ages a little bit, and the reason why is because with such a small sample, the standard deviation of the really small sample was really big, and it made it so that the data was completely not usable. So, first of all, we have a few different things that we can actually calculate for standard deviation. Technically, this you cannot calculate standard deviation for game playing ability on a scale of 1 to 7 because 1 being not playable, they're not good at playing, 10 being extremely good at playing. It's not actually quantitative data, that's qualitative. So we're going to be able to do it on the score of the detective exam, and we're also going to be able to do it on age. So let's go ahead and do it on age really quick. So we're going to put this right over here, and so now we're dealing with a sample, and what the question says is when you look at a sample size of 200, because now we have 194 more people that decided to play, we're going to see how this sample how this can be generalized and what we can expect from the entire population. So there's two ways to do this. We can do equals standard deviation sample, so STDEV sample, and just .s, highlight it, and it gives you a standard deviation of 6.957. 6.957. And I would encourage you to just leave it just like that, and we're going to leave it in Canvas, or sorry, we're going to leave it in Excel just like that. The other way to do it, which I'm going to put it right here, we can do equals average, and then we can do equals this minus 50, and just drag this all the way down. So this gives us the deviation from the mean. Okay, then this is the squared deviation from the mean, because what we're going to do now is we're going to do equals, and we're going to do the symbol to square it. So, and then we're just going to drag it down, and notice once again that's that upwards chevron looking thing, and then square it. And then we're going to sum it all together, so equals sum, and then this right here is the sum of squares. And then we're going to do equals this divided by, and now it's n minus 1, so it's going to be 5. And then we're going to, so this right here is the variance, and this is the sum of squares. Let's wrap text, and then we're going to do equals square root of the variance, and you're going to notice it gives us the exact same thing. So there we go. So coming right down here, I made this fun little calculator, and all that you've got to do is change the variance, or change the standard deviation, and if you change the standard deviation, it changes everything, right? So yeah, let's take a look at this. First of all, we've got the mean. The mean is right here, the mean is 50. So I put the mean right here, the mean is 50. And the sample standard deviation is 6.95701. Okay, so what we did here is we now have standard deviation limits. Okay, so the limit, if I want to know what is the mean, we've got the mean right here. The mean is 50. So let's make this bold. And then right here we also have the standard deviation limits. Let's make this bold if you want. Here, I'll actually make this in orange so that way you can see it a little bit better. These are the limits. And when we have these limits, what we're saying is that right here is exactly one standard deviation from the mean. Okay, so at 56.96, that is exactly one standard deviation above the mean, and at exactly 43.04, that is one standard deviation below the mean. And you notice the formula is right here, which is the same as x bar, um, x bar minus one standard deviation. Then this right here is x bar minus 2 standard deviations, and then this is x bar minus 3 standard deviations. And the reason why it's x bar is because we're dealing with a sample, so same thing, x bar plus 1 standard deviation, x bar plus 2 standard deviations, and then x bar plus 3 standard deviations. And so literally what I do is I take this, okay, the standard deviation, so equals this, equals this, and then equals 2 multiplied by the standard deviation, then equals 3 multiplied by the standard deviation, equals 2 multiplied by the standard deviation, and then equals 3 multiplied by the standard deviation. And so what you'll notice is what this is right here is 50 minus, so it's 50 minus this gives you this. 50 minus this gives you this, and 50 minus this, 50 minus 1 standard deviation from the mean gives you this limit right here. And so what I want to know is I want to know how many individuals, if there are 200 people playing, how many individuals are going to be above 56.96 years old, okay? How many people are going to be above? Now, this isn't one of those things where it's, inclusive, exclusive. This is more theoretical. And so, when I say above or below, don't worry about, whether or not that's inclusive or exclusive. Just look at the value right there and say, okay, 56.96. And you'll see the number of individuals in each standard deviation. If it says, like, for instance, if there's only 192 people playing, it's going to give you 65.28. Just round this right here to 66 people. That's 66 people are in here. Round this right here as if there's 26 people in there. So just round it. Round this as well. So, because it is just theoretical, and it's just saying, how many people are generally in that standard deviation. It's not a perfect science. It's, because a perfect thing is that's the quartiles, the location of data. This right here, we're talking about standard deviations. Standard deviations is how spread out it is. It's not necessarily, the same as location. So, we've got 1 standard deviation above, 2 standard deviations above, 3 standard deviations above. So if I ask you how many individuals are less than 70.87 years old, what you have to do is you have to add up all the people that are in all of these standard deviations combined. So I did this already. So what I did is I'm just going to delete this and do this for you. Okay, so watch this. I'm really excited about this, because I don't know, these things just get me excited. So equals 0.34 multiplied by the sample size, okay? And notice there's 34% right there. So equals 0.34 multiplied by the sample size. Whoops, Control Z. So 0.34 multiplied by the sample size. And then, wow, I just keep on messing up, equals 0.34 multiplied by the sample size. And then right here, you're going to have 0.135 multiplied by the sample size. And then this one, yep, you guessed it, is equals 0.0235 multiplied by the sample size. And then this one is equals 0.0015 multiplied by the sample size. Okay, and then same thing over here, equals 0.135 multiplied by the sample size. And then this one right here is equals 0.0235 multiplied by the sample size. And then lastly, once again, it's the exact same thing as the other side, but equals 0.0015 multiplied by the sample size. Okay, so if I ask you how many individuals are going to be above 50 years old, how many people are going to be above 50 years old, you just find 50 right here, and then do equals sum, and you just add up all the individuals that are greater than 50. So this is 100 people are greater than 50. Now, if I were to say how many people are greater than, 56, they're older than 56.96 years old, so equals sum of all these people right here. Okay, so older than 56.96. But if I were to say how many people are between 43.04 years old and 56.96 years old, I would do equals sum, and I would add these two together, and I'd say these are the number of individuals that are above 43.04 years and below 56.96 years old, which I really should have done a much rounder number. So, but this is between 1 standard deviation below and 1 standard deviation above the mean. So this kind of gives you an idea of, just look at it. But once again, if I were to have had this, it'd be a lot easier, right? I'd say how many people are above 35. I would just add all of these together. How many people are below 65, are younger than 65? I would add all these together. How many people are between 45 and 55? You'd add these. And where a lot of people mess up is they forget to include, that's fine. They forget to include both of these point threes. They forget because they're like, oh, it goes right to there, but that's only 99.7% of the data. Don't forget the last 0.6. The last 0.3% of the data. So that is how you do the last question, and thank you so much. Hopefully this was beneficial, and I'm going to put this calculator up there for you guys. But even though you have this calculator, please, please, please practice doing this by hand. The more that you do this, which this, by the way, wasn't supposed to be there, the more that you do this, the better you're going to get at it. So just keep working at it.